Hello and welcome to Mathematics Elucidation by SB Sani. Now, through this video series, we're going to be learning mathematics in a very simple style and with the explanation being explicitly. Um, it surprises me when I hear some people do express their hatred for mathematics, that mathematics is too this, is too that, is too complex. Well, that may be due to the fact that the background they have in mathematics is not all that solid. Because in mathematics, you've got to know the basis. You've got to understand the basis. Because when you do understand and know the basis, mathematics becomes so easy. So I am your instructor and your tutor throughout this video series, and my name is SB Sani. As you can see right there on the screen, SB Sadiq Babatunde Sani, and I'll be explaining different topics in mathematics in a way that has never been expressed to you before. I want to welcome you once again to this video series. I pray that as you watch through this series, you're going to understand everything that is being passed on to you. God bless you as you watch through this series. Welcome once more again. Let's get started. The basis from the nitty gritty. Understanding the basis and principle of mathematics is really very essential. As far as I'm concerned, if you want to be good at mathematics, you need to grasp the full knowledge of the topic, subject of formula. What I'm trying to say is this. In mathematics, we always try to find, determine, calculate, solve, find. We are always looking for something. Now, the process of you looking for something in mathematics is known as subject of the formula. So, in one way or the other, you employ subject of the formula in everything you do in mathematics. So if you really want to be good at mathematics, you need to understand fully this topic, subject of the formula. But before diving into that, I would like to explain the underpinning of mathematics. Let's get started. I'm sure you guys are really going to be so fascinated by all of this explanation as we move along steadily with me. Arithmetic. We all know that there are four arithmetic operations, namely addition, subtraction, multiplication, and division. So if I operate 3 plus 2, which will be equal to 5, we could look at these in two ways. First, 3 plus 2. Second, 3 plus 2 equals 5. The first designates a mathematical statement which can be called a mathematical expression, while the second is also a mathematical statement which can be called a mathematical equation. So the question comes in, what is the difference between the first and the second? Answer, the first does not contain the equal sign. As you can see, 3 plus 2, no equal sign. While the other do contain the equal sign. As you can see right there, 3 plus 2 equals 5. So it is not down to this. When is a mathematical statement an expression or an equation? Answer, in a statement, if it contains an equal sign, it is called an equation, like 3 plus 2 equals 5. While if it contains no equal sign, it's called an expression, like 3 plus 2. So what I'm trying to say here is this. If you look at the mathematical statement and you have it an equal sign, then you call that mathematical statement a mathematical equation. It becomes a mathematical equation. While if you look at the mathematical statement right here, if it's got no equal sign, then it is called a mathematical expression. So what's a mathematical statement? I'm sure that's the next question you guys are going to be asking me. You know what is a mathematical expression and what is a mathematical equation. Next thing you want to be asking me is what is a mathematical statement. But first, let me illustrate by a real life situation. Now, let's assume there's a teacher asking his student this question. If they get 3 pets and that gave her 2 more pets, how many pets we should be having all together? And the student answers in this manner. She will be having 5 pets altogether, sir. Now teacher will be like, good, way to go, kid. Now in a nutshell, if the teacher is to ask the question by writing it on the board for the student, he would have to put it down in this manner, 3 pets plus 2 pets. Likewise for the student, he or she is going to answer the question in this manner, in in written form 3 plus 3 equals 5. What has happened is that the statement altered by the teacher, which is the question asked, has been coded into written format using mathematical characters. In this case, numerals being operated with the specific operation sign. Another mathematical character, that is the plus sign. What I'm trying to say here is this. We make a statement, usually orally, because we could communicate in oral form or in written form. So if we make a statement orally, we want to put it in a written form. We'll make use of some characters. For instance, if I speak a name like Shade, now Shade is a name. That is a statement. If you look at it, just in some ways like that. I'm just trying to point out that something. Now, if you look at it, assuming Shade is a statement, of course, I just make the statement Shade. Now, that is, I'm making it orally. But if I'm to put it down in written form, I would have to make use of the characters. And what are these characters? The letters of the alphabet. That is Shade, S-H-A-D-E. Now, making use of S-H-A-D-E, all these are characters and they are letters of the alphabet. By combining these characters, I've been able to express the statement I've altered orally in written form. So the same thing goes for mathematical statement. You could like say this, that 3 plus 2 equals 5. But if you have to write it down, what do? You make use of mathematical characters like the numerals and the arithmetic operation signs and also the equal signs. So once you try to code an oral statement being altered mathematically into a written form, you make use of mathematical characters. Mathematical characters like the numerals, the operation sign, the equal signs, the less than, the equivalent signs, the set notation signs, and so on and so forth. So, we can now say that a mathematical statement is an expression written down by using mathematical characters. For instance, I have 3x plus 5, 5 minus 7, x squared plus 3x minus 5, x to the power of 4 minus 5x plus 1 equals to 9. All these are mathematical characters. Why are they mathematical characters? Or why are they mathematical statements? All these are mathematical statements. Why are they mathematical statements? Because they are all written down using mathematical characters. The characters we're having there, like the numerals, the 3, the 5, even we know we're making use of the letter of alphabet as a mathematical character. That goes in algebra. But the thing is that they are all mathematical statements. Why are they all mathematical statements? Because they are written down by using mathematical characters. Algebra process. Yeah, algebra process. Now, what is algebra? Algebra is a branch of mathematics in which symbols, usually letters of the alphabet, represent unknown numbers. What am I trying to say here? For instance, if I operate 8 plus 3, which is going to be equal to 11, is an arithmetic equation. Now, I could decide to make this 8 to this form. 2 times 4, because 2 times 4 is still the same thing as 8. Now, you should know in mathematics, bracket means multiplication. That's one of the functions of bracket. We're going to talk about the other function of bracket later in the course. But right now, you need to know that bracket in mathematics means multiplication. So 2 bracket 4 also means 2 times 4. So still the same thing. Now, if I use x to replace 4, then I'm going to be having, instead of me having 2 bracket 4 right there, I will have 2 bracket x plus 3 equals 11. Now, there's one thing we need to know right there. If I have 4x means 4 times x, which also means 4 bracket x, or means x plus x plus x plus x. Remember that multiplication means multiple addition. Also, if I have 13xyz, 13xyz means 13 times x times y times z. Now, let's check this out too. If I have 14x squared means 14 times x squared. If I have x cubed, mb, it means x cubed times m times b. If I have minus 2k, it means minus 2 times k. So what I'm trying to say is this: if you have number and letters being written together, they actually means that they are multiplying themselves. Also, if you have letters being written together, they actually mean that the letters are multiplying themselves. As you can see right here, these letters are written together, but they actually means that they are multiplying themselves. So whenever you say letter, uh, um, number being written together, it means that they're actually multiplying themselves. So therefore, 2 brackets x will mean 2x, because you know that 2 brackets x means 2 times x, which is going to be 2x. Now this is an algebra equation. So let's say that x represents 4. So the value of x is 4. That is, from what I've shown us here, we know that the value of x is 4. If we solve this algebra equation, we're going to get the value of x as 4. Now, the unknown is x. Why is the unknown x? Because if I give you this algebra equation to solve, I know 3, I know 11, I know these 2, but it is only this x that I don't know. That is what I'm actually going to look for. So what you're going to look for is the unknown, because if it is known, it doesn't have to be looked for. It is because it is unknown. That is why we're looking for it. So any letters we see in an algebra expression and equation, they are all known as the unknown. Now, if I give you this algebra equation to solve, now we before solving it, x could be any value. Though we know that x will be 4 because of the expo I've shown you guys right here, that x is 4. But before we solve it, x could be any value. X could be 1, x could be 2, x could be 3, 4, 5, 6, 300, 400. X could be Shade, x could be Chinyere, x could be Chima, x could even be SB himself. So what I'm trying to say is this: that you don't know what the actual value of x could be. X could be any value. It therefore means x could change. So if x could change, it means x will what? Vary. So when something varies, which is a verb, and if I did my English very well back in school, I know that the noun for a verb varies is variable. So therefore, I would say that x is a variable. So what am I trying to say here? What I'm trying to say here is this: any letter that is found in an algebra expression or an algebra equation, those letters are known as variables. They are known as variables. Why are they called variables? Because they can change. Because they vary. Now, if I have 2x plus 3 equal to 11, now we know that x is known as the variable. So the unknown is also known as the variable. Coefficient of a variable. Coefficient of a variable is the numerical number, fraction or decimal beside the variable, which means the number multiplying it. For instance, in this equation, the number 2 is the coefficient of variable x. Why is the number 2 the coefficient of variable x? Because the number 2 is the number beside x, is the number multiplying x. So number multiplying the variable is known as the coefficient of variable. So in this case, 2 is the coefficient of x. Why? Because 2 is the number beside x, or 2 is the number multiplying x. If I have this equation, 5 over 6 is the coefficient of x, minus 3.6 is the coefficient of k, 12 is the coefficient of m squared. Why is 12 the coefficient of m squared? Because m squared is the variable and 12 is the number beside m squared. So it therefore means that 12 is the coefficient of m squared. Now, in this algebra equation, 2, 3, and 11 are known. They do not change. So, because they are known as the constant. And constant means something that doesn't change. So, they are known as constant. Why? Because they do not change. So, any numbers that is written in an algebra equation or an algebra expression, those numbers are called constant. Why are they called constant? Because they do not change. Now, It therefore means that an algebra expression or an equation consists of variables, otherwise known as the unknown, and constants. Now, check this out. 2x plus 3 is an algebra expression. 2 plus 3 is an arithmetic expression. 2 plus 3 equals 5 is an arithmetic equation. 2x plus 3 equals 11 is an algebra equation. Now, let's break this down so we can understand very much. 2x plus 3 is algebra expression. 2x plus 3 is algebra. Why is it algebra? Because it contains letter. Why is there an expression? Because it got no equal sign. Now, 2 plus 3 is arithmetic expression. Why is it arithmetic? Because it got no letters. Why is it expression? Because it got no equal sign. Now, what if 2 plus 3 equals 5, which is an arithmetic equation? Why is it arithmetic? Because it got no letters. Why is it an equation? Because it got the equal sign. Now, 2x plus 3 equals 11 is algebra equation. Why is it algebra? Because it got letter. Why is it equation? Because it got the equal sign. So I believe we should be able to differentiate between algebra expression, arithmetic expression, arithmetic equation, and algebra equation. We need to know why are they algebra and why are they arithmetic, and why are they expression and why are they equation. So I believe up to this point we understand everything under this. Terms, monomials. Now, if a collection of expressions are added together, each expression is called a term. Now, monomial means one term. What am I trying to say? For example, if you have 2x plus 4y squared plus 5, 2x is a term, 4y squared is a term, 5 is a term. There are three terms in this expression. Now, each of these terms or each of these expressions making these expressions is called a monomial. So another name for a term is a monomial. So this 2x is a monomial, 4y squared is a monomial, 5 is a monomial. Now one thing you should know that a term is separated either by plus or minus. A term is never separated by multiplication or division. For instance, this 2x means 2 times x. So what you should know is that the sign between these two and this x is multiplication sign. Because these 2 and this x are separated by the multiplication sign, it doesn't mean that they are different terms. No, they are not. They are the same term. Even if you have 2 divided by x here, they are still going to be the same term because they are separated by the dividing line. But if you check this one out, 2x plus 4y squared. Now, this 2x is going to be a term on its own. This 4y squared is going to be a term on its own. Why? Because the sign between both of them is plus. So, plus splits off terms. Because it's plus in between them, then it's going to be different terms. Likewise, this 4y squared and 5. Because the sign in between them is plus, so they're going to be a different term entirely. Likewise, if in place of this plus, I'm having a negative sign. Yes, negative and positive separate terms, but multiplication and divisions do not. They stick together. So I believe we now understand how to know the number of terms in a given expression and equation. So in this case, there are what? 3 terms. So for the mathematical statement, 2x plus 3, how many terms is of 2 terms? 2x is a term, 3 is also a term. Now, there are 3 kinds of terms. First is like terms. Now, like terms means if they are having the same kind of variable. Like in this case, they are having the same variable, which is xx. So, because they're having this variable, the same variable, then we can complete them together, either by addition or by subtraction. So, if you have 3x plus 7x, 3x plus 7x is equal to 10x. It's more or less like saying, I have 3 oranges with 7 oranges. 3 oranges with the addition of 7 oranges is going to be 10 oranges. So, if I have x plus x, that's going to be 2x. Like saying 1 orange plus orange, that's going to be 2 oranges. So, if I also have 3x squared plus 5x squared. Yeah, they are like terms. Why? Because the same variable. The variable here is x squared. The variable here is x squared. So you're gonna add the coefficient together, which is 3 plus 5, 8. Then you just put it right there, the x squared, because they are like terms. So 3x squared plus 5x squared, that is going to be 8x squared. So even if I have add minus, then you work it out, you can compute them together because they are like terms. Now the next other one is similar terms. Now similar terms, of course, from the word similar means they have something in common, but they do not have exactly the same variable. As you can see here, this is the variable here is x. The variable in this other term is xy. The only variable they have in common is x. It's not having y right here. So they are similar, not like. Assuming we're having 3xy, 3xy here plus 4xy, and then they would have been like terms. That is, they would have been having the same variable xy, xy. But because in this case they are not having the same exact variable, but they only have x in common, then they are called similar terms. So they are similar if they have something in common, but not exactly the same. So for similar terms, what we can only do for similar terms is to factorize what is common. We can't add them together like terms. Check another one right here, 4xy plus 2yz. Now, yeah, they are having, this one is having xy, this one is having yz. They are having the same, they're having a common variable, which is y, but they are not having exactly the same type. This one is having x, this one is having z, so it makes it different to some extent. But because they are having y as a common variable, then they are similar terms. So even if I have 4cn plus 3cy, yeah, you see that they are similar terms because they have c in common. So what we do to similar terms is to factorize what is common. And what is common is c. So we'll be left with 4n, which is right here. Then we'll be left with 3y, which is right there. So what we do to similar terms is to factorize similar terms. That is the best thing we could do. That is the best simplification we could give to similar terms. We do not add or subtract them exactly like terms. Like terms could be simplified to the simplest by addition or subtraction. For similar terms, the best simplification you could give to similar terms is to factorize what is common. Unlike terms, yeah, unlike terms, this one, they don't have anything in common. Waiting concern bicycle for filling station. Bicycle and filling station, they got nothing in common. So the same thing applies for this. They have 3x plus 4y. They are not having the same variable. They don't even have anything in common. So they are unlike terms. And you should know that for unlike terms, you cannot add or subtract them together. It's just like I've made it our parents right here. 3x plus 4y is not the same thing as 7xy. Please don't ever make that mistake, please. Don't say 3x plus 4y, then that is going to be, just add up the coefficient, that's going to be 7xy. No, this is wrong. No, you can't add them together because they don't have anything in common. The best bet you could do to an unlike term is if they have the coefficient, they have a particular factor as being common to the coefficient. Maybe in that case you could factorize the constant out. But in terms of the variables, they don't have anything in common. So please, the best way is just to leave it like that. Likewise this, okay, it's still the same thing right there. 3x plus 4y is unlike terms. Why? They got no variable in common. Now xy plus 2mz is also, they're also unlike terms. Why? Because they got nothing in common. Mz, nothing appears there. They have nothing in common. So the best thing we'll do for unlike terms is that we leave it as they are. You can't simplify them unless maybe the coefficients are having some kind of factors in common. Combining monomials. How do we combine monomials? Now, for instance, given these three terms expression and these three other term expression, and we are told to add the two expressions together. How do we do that? Now, what we do is we take out the bracket, we want to add these two together. So if we are trying to add um, two expressions together, what we'll do is collection of like terms. If there is no like terms, what we do is collection of similar terms. So it's not always in most cases, or it's not usually in most cases, that everything's got to be collection of like terms. No, there are sometimes that it could be collection of similar terms, and I believe you know what similar terms are. So if you are collecting similar terms, then what you should write is collection of similar terms. If you are collecting like terms, write collection of like terms. If you are collecting similar terms and you are writing collection of like terms, it shows that you don't actually understand perfectly what you're actually doing. Because I do tell most of my students that there is a difference between when you know something and when you actually understand what you know. You can know something, but you may not actually understand it. But when you know it and you understand it, wow, so great. So in this case, what we do is we collect like terms. And what is that? We bring the 3x square first right here. The other one is 2x square. We put it right there plus 2x square. Now the next one is minus 3x. Is minus 3x, please, it's not 3x. So you have it right there, minus 3x. And then other one is plus 5x. Now we bring the constant plus 4. And the other one minus 11. Now I'm still going to explain all these later on because some of you may be like, how is this being joined together? But I'm still going to explain it later on. Then the next thing we have is 3x squared plus 2x squared. That's going to be 5x squared. Now minus 3x plus 5x. That's going to be plus 2x. 4 minus 11. That's going to be minus 7. If you don't understand why minus 3x plus 5x is plus 2x, just chill. I'm going to explain it later on in this series. So the next one is going to be expansion, which is also remove bracket or removing bracket. Now, for example, if I have this um, question, I've been told to remove the bracket. Now, if I want to remove bracket, that means I have to multiply. Remember, multiplication means, I'm sorry, bracket means multiplication. So removing bracket means actually what? Multiplying. So if I want to expand, what you do is this. The term outside there, which is 2x, you use it to multiply each of the term inside the bracket. So the first one, 2x, use it to multiply the first term. What are you going to be having? Multiply the constant first, which is 2 times 2, then multiply the variable, which is x times x squared. Now 2 times 2 is 4. X times x squared, that's going to be x raised to the power 3. If you don't understand how x times x squared is x raised to the power 3, please wait till we get to indices. You're going to understand better. Then 4 times x raised to the power 3, I believe you know that's going to be 4x cubed. Then use that same term to multiply the other one, which is 5x. Then you have 2 times 5, 2 times 5 right there. X times x times x right there. 2 times 5 is 10, while x times x is x squared. Then you're going to be having 10x squared. Now the last one, which is 2x times minus 11, that's going to be 2x times minus 11. Then you have 2 times minus 11, then times this x right here. 2 times minus 11, that's going to be minus 22 times x. Minus 22 times x, of course, you know that's going to be minus 22x. Then what do? You bring each of them together. 4x to the power of 3 plus 10x squared, because the sign in front of 10x squared right here is plus. When you don't see a sign, when you can't see a negative sign in front of the number, you can't see any sign in front of the number or a 10. Know in your heart that that sign is plus, is the plus sign. Then the sign you have here is minus 22x. So you bring it right here, minus 22x. Now, I told us that I'm going to explain some things. Now, there are these things that we just need to know. Minus times plus is minus. Plus times minus is minus. Plus times plus is plus. Minus times minus is plus. So you should know that whenever different signs are multiplying themselves, the result will be negative. plus times minus negative. But whenever the same signs are multiplying themselves, the result will be what? Positive. It's just like where when you're having the same thing, being the same like things, doing the same thing, then it's gonna be a positive result. But when different things are coming together, the result is gonna be negative. You can't tell a normal person to marry a mad person. The result, the child will never be a positive result. The child, of course, is going to be a negative result. But when a normal person marries a normal person, then the result is going to be a normal person. Also, when a mad person marries a mad person, of course, the result too is going to be a mad person, which is a positive result. But if a positive person, a normal person, is marrying a mad person, then it means it's going to be abnormality. So when different signs are multiplying themselves, it's going to be negative. But when the same sign are multiplying themselves, it's going to be positive. Anyway, don't mind me for the little joke right there. Now, arithmetic manipulation. Now, I told us I'm going to explain all those things I did earlier on, all those minus 3 plus this, because those are very important. From my experience with students, I got to know that most students don't actually grab hold of these things. They miss this part, and once they miss this part, you miss mathematics. Once you grab this manipulation very well, mathematics becomes easy, because when it comes to complex questions, it becomes easy if you could imagine this kind of a thing and you know it straight right up. So if I have 5 minus 4 plus 7 plus 3, it's still the same thing as minus 4 plus 7 plus 5 plus 3. How is this that? No, it is that because whenever you have a number, the sign in front of that number goes with that number. Now, this is 5. Remember I told you, whenever you do not see a sign in front of a number, know that that sign is plus. So if you have 5 here, the sign in front of 5 is plus. Even though you can't see a number there, know in your mind that the sign will always be plus. So the sign in front of a number goes along with the number. For instance, you have this 5 minus 4. 5 minus 4, the order of this minus sign is 4, because this minus is in front of 4. It doesn't mean that 5 goes with this minus. No, it comes from the left. So this one you're having here, you can also rearrange it. It doesn't matter. It still means the same thing. Just rearrange it. You're having minus 4 right there. You're having plus 7 right there. You're having plus 5 right there. And you're having plus 3. Also, if you're having 7 minus 2 plus 4 minus 8, it's still the same thing as 4 minus 2 plus 7 minus 8. What they are just doing right here is also rearranging. What's the sign in front of 4? Plus. So plus 4, if you bring it right here, it's still the same thing as 4. What's the sign in front of 2? Minus. So that is minus 2. So you're having minus 2. The next one is plus 7. And the next one is minus 8. So what you are just doing right here is rearranging. It doesn't change anything. That is why if you have 5 minus 3, it's still the same thing as minus 3 plus 5. Why? Because the sign here is minus 3. So you have a minus 3 plus 5. You are just rearranging it. It still doesn't change anything. So if you understand that. Now, whereby I was talking about the combining monomials, and I have 4 minus 11, which is equal to minus 7. Now, how is 4 minus 11 equal to minus 7? Let's check this out. Now, if I have 5 plus 3, that's going to be equal to 8, right? If I have 7 minus 5, that's going to be equal to 2. If I have 5 minus 7, that's going to be equal to minus 2. If I have 5 minus 5 minus 3, that's going to be equal to minus 8. If I have 5 plus 2, which is still the same as plus 5 plus 2, that's going to be equal to plus 8. If I have minus 5 minus 2, that's going to be equal to minus 8. If I have 7 minus 5, that's going to imply minus 5 plus 7, which is still the same thing as plus 2. Now, if I have 5 minus 7, it's still the same thing as minus 7 plus 5, which is equal to minus 2. Now, let me take it a bit right from here. I know that 5 plus 3 is equal to 8. This one, we all know that. Now, 7 7 minus 5, we all know is equal to 2. Very good. 5 minus 7 is equal to minus 2. Now, minus 5 minus 3 is equal to minus 8. The deal now is this. If we are having the same sign, add the values together and put the sign straight up. Like minus 5 minus 3, they are the same sign. So what do? We add the value 5 plus 3, then we'll put the sign right there, which is going to be minus 8. The same thing when you have 5 plus 3. 5 plus 3 is still the same thing as plus 5 plus 3. So because they're having plus 5 plus 3, they are the same sign. So add the values together and just put the sign straight right up, which is plus 8. Of course, which still means the same thing as 8. Now check this out. If you now have minus 5 minus 2, of course that's going to be minus 8. Then what about this? 7 minus 5. Now you should know that 7 minus 5, if you arrange, is still the same thing as minus 5 plus 7. So what is minus 5 plus 7? That's going to be plus 2. Now in this case, they are different signs. Minus and plus. Now, minus and plus are different signs. So, what do we do when they are different signs? We look for their difference. The difference between 5 and 7, that is 2. Then we look at the higher number between the two. Between 5 and 7, 7 is the higher number. And what is the sign in front of the higher number? Plus. So, the result is going to go with plus. The same thing, if you have 5 minus 7. 5 minus 7 is still the same thing as minus 7 plus 5 if we rearrange it. Now, what is now going to be minus 7 plus 5? Because they are different signs, what do? We look for the difference between them. And what is the difference between 7 and 5? That is going to be 2. Between 7 and 5, which one is the higher number? 7. So it's going to take the sign of the higher number, which is negative. So the deal is this. Whenever they are the same sign, just add the values and put the sign right there. Just like this one too. Add the values and put the sign right there. But whenever there are different signs, look for the difference between the values of the number there. And let the result take the sign of the higher number. Just like you have it right here too. The result will take the sign of the higher number. It's as easy as that. That is how we know plus 8 minus 10 minus 13 plus 16 becomes very easy. Just use this trick and you get it right there. You can also use the trick of your father is owing me 500 naira. How much is he going to be having left if you pay 100 naira? You can also use that trick also, but I believe this is pretty straightforward. But if most of us we are we get used to money, so perhaps that could also be something you want to familiarize yourself with. The next one. So if I have minus 2 times 3, now minus 2 times 3 is still the same thing as minus 2 bracket 3. Now what we do whenever we are multiplying numbers is that we multiply the sign first. Now remember that the sign in front of this 3 is plus. So actually what you're having is minus 2 times plus 3. Now, whenever you are multiplying numbers together, multiplying the sign first. Minus times plus is going to be minus. And then you multiply the number 2 times 3, that's going to be 6. So if I have 4 times 3, 4 times 3 is still the same thing as plus 4 bracket plus 3, which means plus 4 times plus 3. Multiply the signs first. Plus times plus is going to be plus. Then 4 times 3 is going to be 12. So and remember, plus 12 and 12, that's the same thing. So whenever you are multiplying numbers together, multiply their sign first before you multiply the value. Now you shouldn't get this twisted with the one I just finished off. Those ones we just did is addition and subtraction. Please don't get twisted. These ones we are multiplying. Those ones we were adding. So adding or subtracting is different from when you are multiplying. So please take note of that. It's just like what I was talking about here. It's different from maybe when we are adding right there, 5 plus 3. It's different from when I'm multiplying. Now we'll talk about 2 binomials. Like that is, what is binomial? Remember we said monomial means 1/10. From the word mono means 1. So when we talk of monomial means 1/10. So when we talk of bi in mathematics means 2. So we are talking of binomials where means two terms. So if we now talk of two binomials that we are having two terms twice, that is, this is x is a term, 3 is also a term. This is binomial. X plus 3 is a binomial. X minus 5 is a binomial term, binomial expression. So when we're having 2, that is x plus 2 1, x minus 5, another binomial. So we're having two binomials. Now, if we want to expand to binomials, how do we do that? What we usually use is the FOI method. What is the FOI method talking about? The FOI method is talking about using the first term here to multiply the first term in this other binomial, and also using that first term here to multiply the other term in the other binomial. And once you are through with that, you now use the second term in the first binomial to multiply the first term in the other binomial, and using that same term to multiply the second term in the other binomial. So, doing that, x times x is going to be x squared. X times minus 5 is going to be minus 5x. 3 times x is going to be 3x. And 3 times minus 5 is going to be minus 15. Now, what else do we now do? Collection of like terms, which is, of course, they're already collected, so there's no need of collecting it again. X squared is x squared. Then minus 5x plus 3x, that's going to be minus 2x. Then minus 15. Remember, you shouldn't have a problem with this anymore. Minus 5x plus 3x. What you do, forget the letters first, deal with the constant. Minus 5 plus 3, that's going to be minus 2. How is that? Minus and plus, they are different signs. So what do? Look for the difference, which is 2. Then it takes the sign of the higher number, which is minus. Then you put the variable right there. As simple as that. So um, uh, the expansion of this is going to give us this result. And the detail is just right there. That is x times x is x squared. X times minus 5 is minus 5x. 3 times x is 3x. And 3 times minus 5 is 15. Everything I've done right here has been made down in details just there. Just so you know. What if we're having three binomials? Like three binomials. 1, 2, 3. Now, if we want to multiply three binomials, what we'll do is we'll multiply the first two binomials, then the result, we'll use it to expand the third binomial. For instance, if I expand this x plus 3 with x minus 5, the result is going to be x squared minus 2x minus 15, which is what we got right here. Then we use that to multiply the last term, which is going to be, we use each of the term here to multiply each of the term here. Each of the, this one also to multiply this and this to multiply this and this, using the FOI method. So, x squared times x, that's going to be x to the power of 3. X squared times 1, that's going to be x squared. Now, we are through with that one. So we have minus 2x times x, that's going to be minus 2x squared. Minus 2x times 1, that's going to be minus 2x. Then we're also through with that. So we're left with minus 15. Minus 15 times x, that's going to be minus 15x. Minus 15 times 1, that's going to be minus 15. So what do we do next? What we do next is we deal with the like terms. They are already collected, so there is no need collecting it again. We have x to the power of 2. Now, x squared minus 2x squared, what's that going to be? That's going to be minus x squared. Now, if you have a variable and you can't see any number beside the variable, know in your mind that the number is 1. That is, the coefficient is 1. So in this case, the coefficient of x squared is 1. So if you're having 1 minus 2, 1 minus 2 is going to be minus 1. So because we already know that the coefficient of a variable, when it is not written, is 1, we don't usually write the 1 down because it's units. Units times anything will always give you that thing. So x squared minus 2x squared, that's going to be minus x squared. And you know we got it to be minus x squared, which is minus 1, because plus 1 minus 2 is going to be minus 1. Then we have minus 2x minus 15x, that's going to be minus 17x. Then we have minus 15. So the next one is factoring monomials. What do we mean by that? Factoring monomials is simply reversing the expansion process. We know we expand. When we expand, we are, of course, expanding it, elaborating it. But when we are factorizing, we are doing that. Let's see how we do that. But before we dive into that, I'd love to explain factors because we're talking about factors. I remember this is mathematics elucidation. I'm trying to explain everything to the simplest form ever, explaining it explicitly. So, what are factors? For instance, if I have 2 times 4, 2 times 4 is going to be equal to 8. So, because these two numbers are multiplied to give me 8, they are called factors of 8. Now, another way you could get factors so easily is any number that is divisible into a number without a remainder or the remainder being 0. 8 divided by 1, the remainder will be 0. 8 divided by 2, the remainder will be 0. 8 divided by 4 is 2, the remainder 0. 8 divided by 8 is of course 1, the remainder 0. So you see that all these 1, 2, 4, and 8, they are all divisible into it with the remainder being 0. So because they are divisible into it with the remainder being 0, all these numbers are known as factors of 8. Now you can't say that 3 is a factor of 8. Why? Because 8 divided by 3 is 2 remainder 2. It's having a remainder. So because it's having a remainder, 3 is not a factor of 8. Also, if you have 8 divided by 5, 5 is not a factor of 8. Why? Because the remainder is not 0. So, knowing a factor of a particular number is when that number goes in the other number and the remainder is 0, then you know it's a factor. So now we understand the meaning of factors. So, the thing is now common factors. Check 15 and 10. 15 and 10. They have a factor that is common. What is that factor? 5. 5 is a factor of 15. 5 is also a factor of 10. So because they have a factor that is common, what do? We factorize that factor out. We bring that factor out. That is what is called factorization. When we bring out the common factor out of different terms, then the process is called factorization. Because 5 is a factor of 15. 5 is also a factor of 10. So the common factor is what? Is 5. Therefore, bringing it out, then what will now be left here? 3. And what will be left here? 2. How can we get that? We could just simply say 15 divided by 5, that is 3. And we could also say 10 divided by 5, that is 2. Or you could just say that it's going back. 3 times 5 is 15. And 5 times 2 is 10. So that is the meaning of common factor. Common factor means what is a factor that is common to the terms we are talking of. For instance, if you look at 15, 3 is a factor of 15, but 3 is not a factor of 10. Even though 3 is a factor of 15, because it's not a factor of 10, therefore it is not a common factor. Because common factors mean, of course, common means what is here and also what is here. That is what is common. So, talking about what is common, that is also a factor, is 5 in this case. So, the next thing is now S common factors. We know the meaning of common factor. So, let's talk about S common factor. Let me illustrate first. If you have S plus 4, S plus 4, we know that there is a factor that is common, 2, right? Now, if you factorize 2 out, you're going to be left with 4 and 2. Also, these 2, you have these 2 right there. We can also say that there's something also common again. What is that? 2 again. So if we factorize that, we'll be left with 2 plus 1. Then if we multiply the outside, we'll have 4. Then we'll be left with 2 plus 1. Now, there's nothing else that is common here except 1. And whenever 1 is the highest common factor, and there's another common factor outside here, we do not like to factorize that. So we are left with 2 plus 1. So what has happened here is this. You saw that when we factorize, we add a common factor here, which was 2. We brought it out. But here, we also have a common factor here, which is 4. So between 2 and 4, which one is the highest? 4. It shows that 4 is the highest common factor. So what this is trying to say is this. Once we get the highest common factor, we can't simplify further again. Let me explain better. Between 8 and 4, what are the factors that are common to the two of them? Of course, 1 is a factor that is common to the two of them. 1 is a common factor. 2 is also a common factor. 4 is also a common factor. Out of all these common factors, which one is the highest form? That is the idea of HCF. HCF means get all the common factors within sets of terms and pick out the highest. Now, why do we always pick out the highest? We always pick out the highest common factor because by using the highest common factors, it takes it down to the simplest form of that term. As you can see right there, even when I factorize 2 out of these two terms, it still gave me a term which is also factorizable. But if I had used 4 straight right here, which is something like this, it gave me the simplest form, 2 plus 1. By factorizing the highest common factor, I can't simplify it further. So factorizing the highest common factor takes you to the simplest form of that expression. So this is the idea of HCF, highest common factor. So when we're talking of factorizing monomial, we love to use HCF, the highest common factor. So okay, 15 plus 3. Trying to elaborate when I said that 3 is a factor of 15, but it's not a factor of 10. So even though 3 is a factor of 15, it's not a factor of 10. Therefore, you can't say that 3 is a common factor. So we know the meaning of common factors, then we now know the meaning of highest common factor, and we know their implication. The implication of the highest common factor is to bring our expression to the simplest form. So, just like that, 8 plus 4 is going to be equal to 4 bracket 2 plus 1, and the highest common factor is 4. Now, if I have algebra expression like 4x squared plus 12xy, now in this case, the highest common factor is 4x. So what do? We factorize the highest common factor, and we'll be left with what? X, because we've taken 4x out, so we'll be left with 1x right here. And also because we've taken 4 out of 12, we'll be left with 3. Because we've also taken x away here, we'll be left with y. So that is how we get the highest common factor for algebra. Another way you could also do, if you want to take it back, you're really sure about, or you want to be so sure about what you're doing, come expand it back, it's going to give you the same thing. 4x times x is going to be 4x squared, and 4x times 3y is going to be, of course, 4 times 3 is 12, and x times y is going to be xy. So that is for that. Simplifying. So the idea of simplification is to use the highest common factor, just like this same example right there, 4x squared plus 12xy. The highest common factor is 4x. Then we have x plus 2y. So you see that right now we can't simplify this further. So when we talk about factorizing monomials means simplifying the monomials. So when we're factoring monomials or factorizing monomials, it actually means simplifying the term. So for example, if I'm told that 3x minus 4y is equal to 2, what is the value of 9x minus 12y? Now this is the question we ask. What is the value of this? Now remember, if you are given any term in mathematics, always try to simplify first. Simplification is very paramount in mathematics. Always try to simplify first. So if I have 9x minus 12y, 9x minus 12y could be simplified to this. So if we simplify 9x minus 12y, of course, it's going to give us 3 bracket 3x minus 4y, because the highest common factor is 2. And what will be left? 3x minus 4y. But remember that I are told that 3x minus 4y is 2. So if 3x minus 4y is 2, therefore means anyway I say 3x minus 4y, what will I put? 2, because that is equal to 2. So instead of me having 3 bracket this, I'm going to have 3 bracket 2. And remember, what is 3 bracket 2? 2 times 2, which is going to be equal to 6.